On today's show, we discuss the different types of studies that can be done to answer statistical questions. So we're going to look at three different types of studies that can be done to answer statistic questions that we're going to ask through the rest of this unit. So let's dive into the first one. So the first type of study that we can do is an observational study. And the key word there is observational. So here's an example of an observational study. A study investigated whether boys are quicker at learning video games than girls. So they randomly selected boys and randomly selected 20 girls to play a video game that they've never played before. The time it took them to reach a certain level of expertise was recorded. So let's talk about why this is an observational study. It's an observational study because they just sat there and watched them play. The researchers didn't do anything. They kind of just collected data. They didn't influence the kids at all. They just said, you play this video game, and they saw how long it took them to reach that certain level. The way I like to think about observational studies is you are sitting on a park bench and just watching things go by. You're watching things go by and counting or collecting data that way. Observational studies aren't that great because you don't have that much control over them. The key thing there is that randomness. You need to randomly select our participants. Randomness is going to be a key thing in all of the types of studies we look at today. But observational studies are studies where you sit there, you watch what's going on, and get your data that way. You're not influencing anyone. You're not really asking anyone questions. You're just sitting there and collecting the data. There's that random piece that you randomly select who you're using for this observational study to reduce the bias. That randomness takes care of making sure that you're not picking kids that are good at video games because you just randomly selected them from a general population. Surveys. Surveys, we know what surveys are. Surveys are when someone comes up to you and asks you questions and you give them their responses. So a study is conducted to determine the number of students who do not like social studies throughout the school. As students entered the building, every 10 student was asked if they had a favorable view or an unfavorable view of social studies class. The students' responses were recorded. So here's the key things with surveys. We need a representative sample. How are we getting that representative sample using randomness? We need a random sample that represents the entire population. So as students entered the building, they just picked every 10th one. That's a very good way to get a random sample because every 10th person is entering the building. You're getting a representation of the entire school. But you're doing it randomly. You're not just picking a certain math class. You're not just picking a certain social studies class. Because as you ask the AP US history kids, they probably like history a little bit more than the regular US history kids do because they're challenging themselves for that AP US history. So asking just the AP US history kids is not a representative sample of the entire population. So that our sample needs to be randomly selected, which that every 10th student does, but also needs to be representative of the population we're looking at. You can't survey math teachers and say, do you like math, and expect that applies to all teachers. You have to have whatever you sample has to be from some general population, some overall population. So surveys are very common. Polls are surveys, questionnaires are surveys. There's a lot of surveys that can be done. But there needs to be randomness, and it needs to be from a representative sample of the population. So one thing about surveys and also observational studies that we talked about before is that it shows patterns. It shows patterns between whatever you're collecting. So maybe you're looking at the relationship between gender and favorite subject, but it can show patterns and relationships in data. It can show patterns and relationships. However, the thing with surveys is you don't get cause and effect. There's no cause and effect relationship. So you can't say that, let's say you were looking at gender and favorite subject. With a survey, you can't say that a person's gender caused them to like a certain subject. There's no cause and effect relationship that we get from surveys and observational studies. We just see these patterns and can describe them. So how do we get a cause and effect relationship? That's what we have experiments for. So a study determines whether taking aspirin regularly helps prevent heart attacks. A large group of male physicians of comparable health were randomly assigned equally to take an aspirin every second day or taking a placebo. After several years, the proportion of the study participants who had suffered heart attacks in each group was compared. So some key designs of an experiment. Key designs of an experiment is we have a control group. We have a control group to compare. To compare what? To compare what? To compare a treatment. The key things with experiments are that we have a treatment being administered. Me as the researcher, I'm giving you the aspirin and I'm not giving that group the aspirin so I can see the difference, to see the effect of that aspirin. So that treatment needs a control group to be compared against. So one group got the aspirin, that's our treatment group. The other group got the placebo. A placebo, so in this case, they'd probably be taking some like sugar pill. So they think they're taking a pill, but they're not actually taking the aspirin. So we have a treatment group and a control group. How did they get assigned to these groups? The key thing is there was random assignment. There was random assignment. That random assignment takes care of the variation that's going to occur between the subjects of the experiment. So we didn't assign all the good people to the aspirin, the healthier people to the aspirin group, and the less healthy people to the control group. No, they were randomly assigned. The researcher had no effect of where they ended up. They ended up in one group or the other group. So that random assignment there limits the bias. That random assignment limits the bias that can happen from a researcher, the bias of the different people's, the different subjects, because not everyone's going to be the same. So random assignment takes care of that. So for an experiment, you need a treatment. It's very clear that it's an experiment when you're giving people treatments. You get this pill, you don't get that pill. You run a mile, you do not run a mile. You drink this energy drink, you don't drink the energy drink. So treatments are key to experiments. And you want a control group to compare that treatment, because maybe actually the aspirin doesn't help. So the control group will help you determine if it's actually helpful, if it's not really helpful, or if it's actually harmful. Randomly assigned. And when we do this, when we have that control group and when we have that random assignment, we do get cause and effect relationships. We get cause and effects relationships. Experiments are nice for that, but they're hard to design properly and conduct properly to get cause and effect relationships. So at the end of the experiment, after they collect the data, administer the aspirin to people, and then do some statistics, they can actually conclude at the end of the experiment, because it was designed properly, that taking the aspirin caused the number of them to have heart attacks to decrease. So they can say the aspirin had this effect because it was an experiment. Whereas our surveys and our observational studies didn't have that cause and effect. We still see patterns with experiments. We still see patterns, but we actually get that cause and effect relationship due to our control and due to the treatments and control groups and our random assignments. Those are the key features for experiments, and we're going to spend time in class deciphering between the two. Is this an observational study? Is this a survey? Is this an experiment? And we'll even design an experiment in class using this as the guidelines of treatments, control groups, and random assignment.